Thank you very much for the introduction. Everybody, thank you, and CEAD, thanks for the opportunity to present an actual use case which we've done for the company Shell a couple of years ago already. And slide is actually a little bit of an introduction about an actual issue they had at a production facility in Nigeria. Just before the corona pandemic started, they were short of what they call seals. This product what is standing over here. The complete sub-assembly could have been exchanged, and that was a very time-consuming and expensive exercise. And within the company Shell, they were looking for different options. And the short lead time was required due to the start of the raining season in Nigeria, and therefore they came with a workflow. The workflow was proposed by Shell Energy Transition Campus in Amsterdam, and they studied the opportunity to 3D print the seal covers and used an intact object in Nigeria, 3D scan that, get the data from the 3D scan to the Netherlands. They evaluated that and contacted Polyproducts Enlarged to reverse engineer and 3D print that. The scan of the part exactly looked like this. You see that even the logo data was secured, and this was a very good basis for us to start. We did not decide to continue to print this file directly, but use it as a basis to reverse engineers and also get a printing strategy available. A little bit of enhancements. The position of the holes were critical because it needed to fit directly to the counterpart, and there was a sealing actually over here in this depth row, and that was crucial as well as the overall dimensions. To us, this was not the most optimized 3D printing part because the complexity is relatively low, and there could be other ways, but the speed and the speed of installation was the most crucial part. 2 days after the arrival of the 3D scan, we had the first results, and we shared that with Shell. The printing strategy was defined. We used the CFAM Prime from CEAD to make these first models, and that is the first actual example of something. We forwarded that back, and there were some feedback and things going back and forward, but in the basis, Shell believed that we were in a good position to have the production of these covers in a relatively short time to the installation in Nigeria. Probably some of you heard about Angelina Go, 3D printing technology manager at Shell. She turned out to at the end to comment a little bit on this project, and she believed that over the replacement of the complete sub-assembly, a great cost reduction was received by over 90%, and it was even more important to them, and we learned that throughout the project, that spare parts should not be all physically in a warehouse, but spare parts should also be made digitally available, and therefore the digital warehouse strategy vision that Shell has was a great example to make this. I actually asked them to ship 2, 3, 4, 5 extra covers to the plant in Nigeria, and they said absolutely not, because the philosophy is that we know that you can make them, you qualified the materials, and you have the digital copy available. At the moment we need a few more. We know that the lead time is short, and we have a digital inventory rather than having physical products in a warehouse in Amsterdam or in Nigeria. You see that on the other side, those will turn it around very quick. The cover has been finished, we decided to have one fiber coating on top in order to get a little bit more impact strength, just to be on the safe side and cover it up in a nice color. So this is actually the finished product which we shipped to Nigeria, and they have been installed, I guess it was in the early days of 2019 already. Thank you for attending this actual use case, and thank you for paying attention to this job we've done. As you can see, we have a booth where we practice everything around large-scale additive manufacturing as a service using the CEAD equipment. Thank you very much.